The one-liner is it's a language for people who have concurrency problems and want to go fast.
All memory in an actor can be completely independently garbage collected from any other actor. So actors are fully independently collected, but it's on this basis of region-like memory management.
I think one of the things for that's interesting is in a lot of cases it's like, well, what might you want to take from other languages? And I have a hard time answering that because it's like, well, what is the problem that somebody's trying to solve? And what's the right way to solve it on the basis of what Pony is doing, right?
An actor is sending a message to a collection of actors and being able to take action. The reason I mention it is that it's fundamental to certain kinds of programs.
And sometimes I think you just have to say, we're not going to do that, even though that would be nice, because it just creates areas where it's easy to blow your foot off over here.
Hey, what's going on, folks? It's Mike here, and today I'm very excited to bring to you a conversation I had with not one, but two developers of the Pony programming language. Sylvian Klepsch, who originally designed the language, and Sean Allen, who's a key contributor to the project as well. We sat down and talked about everything from their programming journey to actually sitting down and looking at the Pony programming language code sample and just getting a tutorial or guide to the different design decisions of the programming language. It was incredibly insightful, and I was incredibly grateful to have both their time for 2 hours here looking at the Pony programming language and understanding its development. In fact, the conversation itself, you'll find, was very insightful. It was only planned to be about an hour, but we were having so much fun, we extended it quite a bit here. And again, I think you'll see the excitement in everyone's voice here as we talk about just programming and our love of doing cool stuff. So with that said, again, I'm very grateful for Sean and Sylvian for joining, and I hope you, the listener, will just enjoy this conversation. With that said, let's go ahead and dive into it. All right, so welcome everybody. It's a real pleasure today. I have with me Sean Allen and Sylvian Klepsch with me, who are both inventors and maintainers and contributors to the Pony language, which we have reviewed, and really excited that YouTube has connected us. So Sean, thanks so much for finding that video and sharing it. And I love that both of you watched it and left some comments on the last week in Pony, which we'll talk about here. But I did want to talk, one sort of coincidence here, just as a little introduction, is I was actually at the PLDI in Barcelona in 2017. And I was looking back, that was my first time as a grad student traveling internationally and, these huge conference. And as I was researching for this talk, I saw several actually talks about the Pony language there, or folks who would later contribute or work on projects. So Sylvian, what do you remember about that conference? I believe it was the Curry On portion of that conference.
Yeah, so Jan Vitek, who is, well, first of all, he's completely awesome, but he's also one of my comp sci heroes, and he puts together the Curry On series, and he asked me to come give a talk. It was actually a follow-on talk to a talk that I did in Prague a couple of years earlier. I guess that was the 2015 Curry On in Prague, on where Pony was and what it was doing at the time. And so I got to go down and just chat through where we've been, how far we've come, how much had been added to the language, and more importantly, to the support libraries and sort of the ecosystem around the language. And then also, I think that was the same, that might have been the PLDI, where I was doing the ICOLPS talk as well on how hardware and software developers really have mismatched expectations in a deeply unpleasant way. But yeah, there are a few different bits and pieces of that. That was a particularly good conference, actually.
Was that the Pony 2 years on talk?
Yeah.
Okay? All right. So I put dates together there. All of a sudden, I was like, oh, is that one? Okay. Yes.
And Sean, I'm sure we have crossed paths because we're both New Englanders. And I've actually seen, in preparation for this, several of your recent talks on developer voices, which was excellent, and so on. So I can't wait to get into it. So anyways, I remember Sagrada Familia, I remember Barcelona, I remember it being very hot, and then I remember a talk on Pony there. Long ago, it was in my subconscious. And Jan is a former colleague. I was at Northeastern previously with him. So anyways, though, so that's getting into the future. Whenever I have guests on, I like to talk a little bit about how we got to Pony, and I'm always just curious about your start in programming. So maybe it's just a brief sort of introduction. And Sean, I'm going to throw this to you first. Before we get to Pony, what were the first programs that you remember making? How did you get into computer science and programming and hardware?
I really liked Lode Runner, the video game on my Commodore 64, and I wanted to make Lode Runner. Basically, that's how I started programming. And then I put it down because I went off to college where I met Sylvan, and I don't think we did any computer things there for the most part. Sylvan, a tiny little bit, I mean, other than maybe playing Ultima. I remember playing Ultima, but yeah, and I got my grandmother to get me a book. It turned out it was how to do machine language for the Commodore 64, and I thought programming was really hard. And then I saw an ad in the back of a magazine for this thing called White Lightning, which turned out to be a Big Fourth video game kit for the Commodore 64. And after the trying to do things with machine language, it seemed really, really, really easy at that point. So that's how I got started.
And I'm just going to throw it back to you, Sylvan. Do you have a memory of a first program that you were also writing, or how you got into computer science?
I know exactly the first program I ever wrote, which is I wrote a program to automate star system and star sector generation for the Traveler RPG in Fortran on punch cards. So I used to have to write everything out on punch cards, rubber band them together, mail them downtown, wait for a week, and get my printout back that said syntax error, and try again. So yeah, I remember also the first time I sat down in front of something with a keyboard and a monitor, and I felt like, now this is good. This is a super big change in how this works.
So how many mailings back and forth did you honestly have to do before you got your program working without a syntax error? Or were you very meticulous?
Well, you try to get as meticulous as you can, but since I was, how old was I? 8? I wasn't all that meticulous. So it usually took a few weeks of mailing back and forth. So, 3 or 4 times before you finally get something back that is. And the Fortran compiler was not awesome about the errors it kicked out. So, yeah, it took a little while.
Now, for both of you, since you started off in, a low-level language, assembly, or punch cards, or in Fortran, do you think that helped you later in your career to kind of start at the level where you're thinking like a machine, almost instruction by instruction, when you did move into a higher level language? I mean, Sean, you said it was easy after, starting there.
Yeah, I understand that. But actually, I think this is just my, personal nonsense, but I actually think that's a misunderstanding that really being able to reason about what's happening with your program isn't the same thing as working with lousy tools. And I think there's a misunderstanding sometimes that these lousy tools somehow made us better programmers in the future. And it's not really true. Being able to reason about your program and think clearly, and in fact, better tools that can give you a better capability to reason about different aspects of your program, whether that's performance, security, whatever it is, makes you a better programmer. And I think the idea, it's like, those old grognards with their assembly language, boy, they're the ones that really understand. It's not really true. I think actually, in many ways, the latest generation of programmers have the best chance of being the best programmers because they have all the tooling available to them. They have everything that we've learned in computer science, and we can pass on. It doesn't mean you don't get bad programming, but we had lots of bad programming in the old days too. So.
Yeah, I mean, when I have to deal with LLVM-IR, or like a couple weeks ago when I was writing the .NET IL directly, then yeah, all of that Forth experience and Stack Machine stuff came in really helpful and handy, because it's like, oh yeah, right, I've done this. This is not foreign to me. But I mean, other than that, I don't think it particularly helped with my being like a good programmer. I probably got a lot more out of like my social science teacher in college, who like just refuse to allow me to be lazy in my thinking in any way whatsoever. That probably helped me much more, as a programmer long term than having started with like literally doing like binary one and zeros things with a Commodore 64, where I was like, this is hard. I don't know what I'm doing.
Yeah. Wrongly agree. Philosophy and economics are the key to success.
Yeah, I love this. And especially with today, I mean, we're seeing more and more programming, more and more of the disciplines and folks getting into programming and making it accessible. So I love taking this as evidence to others who, teach and saying, hey, at the end of the day, it's how you think, or at least that's my take on things. So yeah, very interesting. And so both of you kind of started with low-level languages. And Sean, as I understand, you were a bit of a polyglot as far as learning lots of different languages. Was that true, or kind of later on learning, Ada and C and Pascal? And
I think by the time I was in like the 5th year of getting paid for programming, I'd probably learned 40 or 50 languages at that point. I really liked exploring the basic concepts and seeing all the different ways that you could come at them, from like logic-based languages. Like I loved like Prolog was so cool when I discovered that. I was like, wow, this is entirely different. Even just the first time I encountered an algo language, having started with a 4th, was like, whoa, what is going on here? And just trying to learn those but a bunch of them I was just like, it was like, oh, Python, this isn't really that different from Perl, etc. But we like, oh, Oberon over here. Well, this is very interesting. What's going on with this? And Smalltalk, what's going on with this? And very few of them have ever been used in anger, but it was fun for me. It was like it was an intellectual like experience, or just a game to play with things, to figure out how do you do it if it's like this.
Mm-hmm. And I'm wondering if Sylvan, if you had a similar path where we started with 4th, and then as you kind of progressed through, were you trying lots of different languages? And
sure, yeah. Just tons of stuff. It's almost not worth going through stuff. I think that interest in language design is kind of predicated on interest in language usage and interest in what does it mean to be able to express different ideas, and how does a language tend to encourage certain kinds of concepts and approaches and certain kinds of shortcomings and failings. And it was actually considerably later in my career, not until the mid 2000s, when I joined Microsoft Research, in some sense a little bit before that, working with my PhD advisor Sophia Drosopoulou at Imperial, but getting to go to work at Microsoft Research, and my day-to-day job is working with Tony Hoare and Simon Peyton-Jones and Don Syme and tons of other people who are absolutely amazing in the field. I don't want to leave anybody out. Matt Parkinson on separation logic, like just a ton of people. And the idea that all of these things have an impact, it's not that they have a place, right? We give up on things, and that's okay. In fact, it's great. We figure out that approaches we've taken in the past are not working out for us, and we're going to move on to new things. But the impact of language design on the way that we can think about computation is huge. And I think it's sort of built in to the language designer mentality, is this idea of go out and find other things, go out and find other approaches, always be super interested in what someone else has brought to the table, even if the whole package isn't what you're looking for. Right?
I mean, when you mention, and maybe we should revisit some of these folks that both of you have worked with, great language designers, including yourself building a language that other people use. Do you have, maybe let's start with this. Do you have any sort of aha moments when you think about computation, or can you recall points where you kind of looked at an idea and said, oh, I can express it this way, and oh, I can express it this way, and think, functionally or object oriented, or, with an actor model? Or do you have like a moment or a lesson there that speaks to mind immediately?
I mean, yes, a lot. So there's a paper that Matt Parkinson was on, along with some other fantastic folks, on deny guarantee reasoning, and how that is a completely different way to approach guarantees than rely guarantees. Instead of saying, what can you do on the basis of having something or knowing something, it's what can you not do on the basis of having something or knowing something. And I think for me, that was a transformational way to look at things like reference capabilities, and to change my mental model of fundamentally how that math works. So I think that was a huge deal. I think another one indeed was the actor model. And I was lucky enough to talk a bunch with Gulaga on this, and it was extremely interesting, both what you can get out of it and the obvious shortcomings. For example, it's very powerful to think of an actor sends a message to another actor, which then executes a behavior on the basis of its own state, and the state encapsulated in that message. Cool. Or you have the join calculus, where you have a collection of actors that send a collection of messages to a single destination, which then eventually takes action based on its own state and the state of that collection of messages. But what does it mean to have something send a message to a collection of actors? Well, that's not something we can express in the actor model. How isn't that interesting? Like to look at things that are fundamentally not possible in certain models. But then another one is, I'm clearly a huge type systems nerd, and I tend to think of everything in terms of type systems. But another one was talking to Joe Armstrong, who did Erlang, and he just at one point was very annoyed with me and said, "Yes, but how can your type system protect you from a lightning strike?" And it's just a very different way to consider computation. He's bringing a grounded real world perspective in what is failure and what is your failure domain. And the math you did ahead of time didn't protect you against this failure domain. So, but I'm sure that there's more. I should just let Sean have a go.
I don't even remember what the question was. I was just enjoying it now. And at a certain point, as soon as you brought up Joe, I was like, "Oh, is this going to be the lightning strike story?" So I just got into the flow of what you were saying, and I don't even remember what the question was.
Yeah, I'll refresh you. I mean, I feel like Joe was full of all these. I mean, I didn't know him personally, but I always show his comic explaining concurrency versus parallelism to my students with the sort of coffee machine, and just had a really succinct and some sort of image or saying that's stuck in your mind. But I guess to that, and even that comic lead in back to the question is, did you have sort of aha moments when you're programming, or where you kind of changed your how your brain thought about computation? It could have been using a different programming language, or maybe a different paradigm, or maybe reading an interesting paper where you said, aha, that's how that thing works, and now more of the puzzle fits together.
I don't know if I've ever had that experience. Not but I don't know that I've consciously had that experience, right? I mean, I'm sure, because if I look back on what I was interested in my 20s with the programming languages that I designed or any sort of thing, right, which were not really designed or anything, like what I was looking for then versus what I would do now, right? Are just wildly different. But there's not like moments where I'm like, oh, aha, just a thing. But Sylvan's deny capability, deny guarantees one is great. I love that one because, at least related to teaching people Pony, it's much easier to get people understanding reference capabilities in the beginning, not talking about it in terms of what it denies, because people have a really hard time coming at it with that. But there was a moment when that finally, the deny stuff actually made sense to me, and the difference, where I had taught it to people so many times that I was just like, oh yeah, I actually really get that. And I didn't have an aha moment for it, but I had an aha moment of, oh no, I actually have fully taken in and understand like that difference now, right? from having tried to teach it to people so many times. That's more of the ones I have. It's like oh, look, I used to be in this structure and now I'm in this structure. I don't know exactly how I went from one to another, but I'm now over here in this sort of thing, and the world around me is different and I'm different, but I don't really have those aha moments where it's like I actually notice things changing. It's just suddenly one day it's like, oh, I'm in a different place now.
Yeah, that's interesting what you said though about how sometimes a question, well, a few interesting things. One, just over time, I always like to tell folks, look back where you were 5 years, and you probably know a lot more programming than you thought you did. So we're always improving. So even if it is that sort of steady, there's not a Newton moment where an apple falls on your head and you say, "Aha, gravity," or whatever that story, as that story is told to maybe a younger kid. It's a continuous accumulation of knowledge, which is kind of interesting. But also, sometimes if you're teaching it or talking about it, how that can change your model of thinking. As you said, it's like, hey, I can teach this a different way. That makes sense, which I love that. So let me kind of progress this forward. So I think I got us both up to, you two met and went to the same university. Did I have that right? And spent some time in college. Both of you were computer science majors. Is that?
No.
Okay, perfect. Tell me the story.
I mean, I was a social science major. That's what I got my degree in. If there was a computer science degree, I'm not aware of it. I think they had one computer science class that like some dude from like the 3-person math department taught. I think Sylvan would know more about that because he actually took it. Yeah, no, and they tried to find a way to take all of the weird stuff that I was interested in doing and forming it into a degree. So I got a social science degree with an area of concentration in international systems, for whatever that actually means.
Fascinating. Yeah. And Sylvan, what was your path? I want to hear more about this.
I majored in doing nothing, messing around, and moving to Berlin. Yeah, I mean, I read politics and economics, but yeah, there was that one C programming course, and there may or may not have been a well-known buffer overrun in the FTP service they were running on that Nextcube, which meant that you could log into the professor's account. But I didn't show up for class, but I did get an A.
Oh, I love it. Okay, so then let's. I mean, I love, again, because I like encouraging everybody to learn programming at the least because it teaches you one way to think. But again, thinking about the effects on society, economics, politics, right? Having that might be the way forward, right? We're going to need folks to think about how we use a lot of these tools, which. Either of you feel free to comment on at any time. But where does the first programming job then enter for you, Sean?
Oh, okay. So this is good. So I got out of school and I moved to New York, and a friend of mine got me a job fixing computers at Scholastic in their publishing group because he didn't want me to leave and I was running out of money. And the one job that I'd come close to getting, speaks to where I started, was as a speechwriter for Jack Kemp. Almost got it, not quite. And so I was just like, well, I don't know what I'm going to do with my life. And at some point, Sylvan and I were talking. He was like, well, if you learn Perl, you can come work with me, because he and some folks who I'd gone to school with had a company in Boston. So I was like, great, I'll learn Perl. I used to program. And by the time I actually had learned Perl, they were not around anymore. But I was like, this seems like a way that I could make money rather than this like 20-something thousand a year that I'm making in this job, fixing desktop publishing stuff and basically making Quark like not crash on somebody's computer. And so I managed to get myself little jobs for that in some variation of fake it until you make it, and then realized that I really liked the money and decided that if I really liked the money, that I should really actually learn what I was doing, and took that "don't be a lazy ass" thing that a professor of mine had taught me in college and actually put it to use for the first time in my life, and spent like 10 years giving myself a serious grounding like I probably would have gotten if I'd done a comp sci program or something.
Very cool. So a lot of your programming career, then, we can say, is, I mean, self-taught, self-motivated, and teaching as you need. Is that fair to say?
Yeah. But I mean, a lot of people helped me along the way. I got involved early on with BOS, right? And there were a bunch of great people in the BOS community when I was learning C++. There was a guy who was the head of the the development team at MetroWorks that developed their tools,
Mm-hmm.
who was really nice and kind and helped me a lot. There was a guy on a mailing list who helped me all the time with learning C++, who turned out to be, I had no idea who he was at the time. He was just a name, but Neil Stevenson helped me learn C++, from like B mailing list stuff and everything. And it was great. They were just like, they're like, hey, all right, and just continue learning.
Very cool. Very cool. So, Sylvan, take me, from the point where, so I guess after college, did you get into programming? Was there a startup or something in this domain,
Oh,
or?
yeah. I started programming long before university. University was sort of a break from programming, if that makes any sense. Yes, did a startup doing web programming in 1993. We were a little too early, so we folded, as Sean mentioned. And I've done a series of startups, and I've worked in various places like Stanford University, and I'm in the finance industry, and in flight simulators, and stuff like that. So uh, sort of all over the place. 6 or 7 startups, 6, I can't remember. Bunch of startups, the usual nonsense.
Very cool. Very cool. And I know, I mean, this is kind of well documented. I'll put a link in here to, on the actual Pony webpage, kind of talking about how, both of you were programming. I think both of you had been using C and working at, or maybe other various languages at financial industries. And this is where the allure, I guess, of writing a more, how do I say, fault tolerant language starts to arise here. Is that a maybe fair characterization? When does Pony start bubbling up in your mind? I know there's a PhD in between here as well.
Sure. Yeah, it actually started a bit earlier. So it really came out of working on, well, everything comes out of everything in some sense. But I'd say the most concrete stuff was working on the flight simulator, where I ended up implementing a physics engine with Lua on the back end, where actually the specifics of it was doing finite element analysis to do flight models. And so the individual elements were modeled in Lua. And then there was a C++ physics engine that drove those components. And it was all implemented with asynchronous message queues to make it all work. And I think that experience made me really question all of the plumbing work that I was doing between Lua and C++ to make all this work, and look for other solutions and more principled solutions. And that's how I ended up, well, in some sense, later when I was working for the bank, sure, I was implementing a bunch of high performance stuff, but again, mostly in C, not even C++, because this was pre-C++ 11. And for performance reasons, we had to stick with C. Although, interestingly, the bank later hired Bjarne, so I was on a team with Bjarne arguing about when we used C and when we used C++, which that was an interesting thing. I think that was really the germ of it. Funnily enough, at the bank, we did use a bunch of actor model stuff, but that I'd implemented in C under the hood. And it wasn't actually until leaving the bank that I was able to take the time to actually go out and write a Pony compiler and actually put this stuff into practice.
And when you're writing that C library using the actor model, was this because you had, toyed around with other languages, like I guess Erlang would have been around at that time, and just said, oh yeah, must be a better way. Let's, bring in some of that stuff. Is that how that kind of arose, I guess?
Yeah, I mean, in some sense, that long history of believing that there are better approaches, but specifically looking at a combination of reliability and performance needs for some pretty specific in-bank use cases. I haven't worked in a long time. I can just talk about it. We were trying to catch what's called do you know what a prop desk is? These are proprietary traders, people who trade in their own money. And it turns out it's very difficult to know inside a bank what the bank's total position is. I.e., what are you actually investing? What do you own? What do you not own? What's been your delta? It's incredibly difficult because there's so many different systems. And it turns out not all prop desks are run by people who are necessarily in compliance with either bank regulations or the law. And so we were putting optical taps on the connection between the bank and the exchange to monitor all traffic at the packet level, reassemble TCP streams, reassemble UDP packets, to then do deep packet inspection and figure out what the bank's position was based on directly monitoring the physical network connection to the exchanges. And that's the kind of load that you can't really do with Erlang. Much as I miss Joe, Erlang is not the right language for that task. So we needed something that was way higher performance, but also had that the kind of scale and reliability that Erlang really does bring to the actor model. And so that's what led to pursuing that pretty hard.
Yeah, interesting. So, and as I understand, thinking about Erlang, it had its sort of roots in maybe a telecom industry.
Building switches. Yeah. They were building telecom switches for Ericsson, where their scale was absolutely intense, but their performance needs weren't bad at all because all the latency measures were based on human telephone calls. So it was more like UI level latencies than it was like what we think of in the modern world as low latency, where you're dealing with data centers and very, very high bandwidth computations. It was more like writing a user interface, except it's all happening over your telephone. And so how long does it take to connect the call? Well, if it took a third of a second, nobody cares, right? Nobody, and the difference between a third of a second and a half a second, well, still nobody cares. So, but if the call doesn't happen because part of your switch goes down and it doesn't know how to do failover, well, everybody notices. So Erlang really arose out of that very specific set of requirements.
Yeah, interesting. Okay, so I guess in a moment I want to just screen share just so our audience can see Pony if they haven't. But how would you describe it what kind of elevator pitch? And Sean, I'm going to start with you. When you say, I work on the Pony programming language, someone says, what's that? And they're a programmer. How do you sort of pitch them? What's the one-liner?
The one-liner is it's a language for people who have concurrency problems and want to go fast. That's the one-liner. I mean, one-liners never really capture the full truth, but that's the one-liner.
Absolutely. We'll try to capture some of that truth here by showing it. But Sylvan, what would you say for Pony when folks ask, what are you working on?
Yeah, I mean, that sounds very reasonable, what Sean said there. I think Pony's sort of core philosophy is get stuff done, with apologies to Rich Gabriel on the other philosophies. But with this idea that if your program is literally crashing and failing, you're definitely not getting things done. And so you have to be able to get to a program that works. And this might sound trivial, but if you've been around for a while, native code for a while, or really any code, this is not so trivial. And so giving people the right tools, as Sean said, you have concurrency problems. And spoiler, everybody has concurrency problems, right? You have concurrency problems with JavaScript now because the world is an exciting place. Then how do you build on that? How do you give people the tools to rule out entire categories of bugs? Not mitigate problems, but just rule them out. This just cannot, these are bugs that do not happen when you're programming in this environment, it's just not a thing. And finding as many of those categories as we could and lock them out.
Yep. True fact. I am much worse at concurrent programming before I started using Pony than I am now, because there was a whole bunch of things that I used to remember all the time as rules. And I've just sort of baked it into my head that the compiler is going to protect me and take care of that. And I have to remember when I'm working in something that's not Pony that no, that's not the case. He says, having introduced 3 different concurrency bugs that wouldn't have happened in Pony and the F# stuff that I do at work. Oops.
I love that. Yeah. I mean, yeah, design, that's what a proper design can do for you, right? If you have a million core guidelines, you have to remember that's troublesome sometimes. We're humans. So let me get Pony just on the screen for us, just to guide us. And there's already a lot of interesting things I want to follow up with. But let's just, for folks who haven't looked at Pony, give them a chance to go to the webpage, ponylang.io. It's also on, I've got godbolt.org, so folks can just try it out there without any, sort of friction. But let's see here. I mean, we've got the one-liner here. Let me make it a little bit bigger for us too. But open source.
Just a random shout out though of just how completely awesome Godbolt is. Like, if anyone out there isn't using Godbolt for a compiled language, get on it. For any language, it's great.
Yeah, I show my students, and again, that was another one of these aha moments of like, oh, this is how I can like learn or teach assembly, by showing the C or whatever language you're using and the assembly on the right side, and that's how machine works. And you can debug in so many things here. So let's see. So Pony, open source, object-oriented actor model, capabilities, secure, high-performance programming language. I'm going to let folks, check out the sort of what is Pony and these sort of things, but I think it might be best if I just open up a snippet of code and we just kind of talk through it, and maybe you both can give me some I definitely want to talk about the reference capabilities since that's come up here, but let's go ahead and get started here. And I really actually love and this was something that came up, I think, in the video, just the friendliness of the community that you folks have. It seems like for folks who want to try out the language and ask questions, saying just that it's not a dumb question and not to get annoyed is really important. So I just love that. And again, just some things for folks to think about here. But I'm going to go into the Pony patterns, and then if there's a particular example that either of you want to talk about, please do. But I just wanted to show one that was doing something with the actor model with users. So I brought up this one here with transactions here, and just kind of walking through what this looks like here. And maybe it's actually easier to look at the second part first and then what an actor is at the top. I don't know if that'll be a good way, but that's kind of how I parse this here. How's that sound for you both?
Sure. You picked a crazy one too. There you go.
Maybe we'll start with a concurrency one. And I mean, if you have, should we backtrack a little bit and find the hello world?
I'm no, anything's good.
Okay. Yeah. You guys are going to be the experts, and this is going to be an example of, me learning the actor model here and how to think. But we've got, our main here. And so everything's an actor in Pony, correct? That's the way to think of it. Every sort of...
Everything's... I think I'd put that a little bit differently because, of course, Pony has objects and classes that are not actors. Mm-hmm. And instead to think of it as an actor encapsulates both temporal and spatial memory. Mm-hmm. So there's some collection of memory that an actor, in some sense, owns, and ownership can be passed. But there's some collection of memory that an actor owns, and that an actor temporally is only executing when it receives a message, when it executes a behavior. So you send it something, it's a behavior. It asynchronously then goes and does that. So in some sense, you can think of your program. Each actor is a tree of memory. Actually, it's an arbitrary graph. It's not like Rust. It's not strictly tree shaped, but it's a blob of memory. But then those trees form a forest. There's a forest of actors, and all those actors can communicate as long as they have been introduced in the classic actor sense. In other words, they've been sent a reference to another actor. So there's no forced topology to your program. You can create new actors. Actors will get garbage collected if it's not possible for them to ever have any more work. All the things you might expect. But while execution is built around actors, not everything is an actor. And that's actually quite a difference from, say, Gul-Aga's work on the actor model, where literally everything was an actor and that was the only way to encapsulate state. This is a little bit more like a traditional object graph encapsulated within an actor-like structure.
Got it. Okay. And yeah, please do interrupt me if I say anything wrong. So that's a very important distinguishment, that sort of not everything is an actor, because that's, again, the mental model I'm stuck with. So
for a beginning mental model, I think it's okay to boil everything Sylvan said down to everything happens in an actor, right? There's more than actors, but everything happens in an actor.
Perfect. Love it. Okay, so we've got our first actor here where things are going to start, or something's going to happen. And, immediately I see new, so there's some sort of memory allocation here in create, which looks like some sort of constructor. So we're going to do something, or we're preparing to do something here. Fair to say for that much?
Yeah, you've nailed it exactly. So constructors are named in Pony, and it turns out that there's something called create sugar, which is if you don't specify the constructor, it's going to use the one called create. But you can have as many as you want. And new literally is the keyword for introducing a constructor. So because constructors are a little bit different in that they're more like a static method, right? You're not calling them on an object, you're calling them on a type. And main.create is your entry point. It's just like your, int main, int argc, car double star argv. That is your main create env in Pony, where in Pony, that environment, there's a bunch of stuff that's implicit in most languages that you have ambient access to, global access in that. I tend to use the term ambient. It comes from the capabilities world of what capabilities do you have. But in Pony, that's not the case. Nothing is ambient, nothing is global. So in order to have standard in and standard out and your environment variables and all these things you expect to exist, those are encapsulated in that environment that you're passed when your program starts.
Excellent. Okay. And so this environment, should I think about this environment like sort of a context? Is this where I'm going to have some of that, memory, where we're going to share things or look to other actors to talk to, or how should I sort of think about the environment?
It's really just that program initialization. It's really standard in, standard out environment variables that goes into that standard error. But what you're talking about there is super important, and that's actually the things that you're going to start building in your program as it starts to execute. So you'll obviously you start with main create, but usually in a Pony program, you're immediately spinning off into creating lots of other actors, each with their own little roles and maybe even some supervision to go into it and all this stuff. And those things, that big giant object graph gets instantiated from that program entry point, if that makes any sense.
Got it. Okay, great. Okay, so then let's kind of, move one layer in here. Okay, so here we're, establishing some variables here. And already we've got, distinguishment between, some languages have let or var or const or immutable. So here, is there an immediate decision about the mutability here of these variables here in the type system?
Yeah, there sure is. So the most obvious one is the difference between let and var. where let is single assignment and var is multiple assignment. And you can think of this as if var is a bit like a cell. It's like a place where you put something, whereas let is the thing itself. So if you have a var, you might replace it. And most folks are used to only having var-like semantics in a language, whereas let-like tends to be associated with MLs and functional languages. Although actually JavaScript, funnily enough, has a pretty good mechanism for this now. Although they use different terminology. But there's another thing that's hidden in here because of default capabilities, which is there's also a default reference capability for your environment and another one for the shared registers type that you just created. So on that line there, you're creating a new instance of shared registers that will desugar to shared registers.create, and there will be a default capability for that. And in the case of shared registers, that's mute. It's a ref type. It's a mutable type.
I think shared registers is actually an actor in this case, so that's a tag.
Oh, is it?
Go off for a minute, Mike.
I apologize.
Yes,
it
it's
is
an
an
actor.
actor. So that's a little bit different. That's actually a tag capability, but maybe we should put that off when we talk about reference capabilities a little more deeply. But there's really, what I was trying to drive at is your question is actually extremely insightful there, because there's two separate things happening, which is what's the capability over let versus var, which is one level. Can I assign this multiple times? But what is the capability of the thing I'm pointing at? And that's the reference capability. What is this reference to the thing I'm pointing at let me do? Which is distinct from the object capability, which is what does the thing know how to do in and of itself? If that's at all helpful.
That is a common thing that trips people up when they come to Pony. They think, oh, let means that this thing is immutable, and it's no, the thing is not immutable. It says nothing about the thing. It says this name cannot be rebound to something else, right?
Got it. Yeah, that makes sense. Okay. Now, is that an important design decision as we get into capabilities and thinking about, proving, what this symbol is sort of bound to, and not being able to change it on the, I guess, compile time side, or I guess at the runtime side as well. So is that kind of this decision? Yeah, both.
Yeah, definitely. So let bindings under the hood are very often are often more optimized than a var binding. Not always, because sometimes through the optimization chain you can figure out that a var binding is effectively a series of let bindings, and you can rewrite it in the compiler under the hood, particularly LLVM-IR optimization, to say, yeah, you don't really have a cell here. What you have is just a rebound name, so we're going to introduce new names to rebind to. And then we can optimize it. But letting the compiler know up front that this is a name that you're only going to use once can give clarity to that, and let you say, I need this to be as optimized as possible. I don't want to introduce a cell or an indirection here.
Got it. Okay, yes, we have this sort of single assignment here.
Yeah, very much so.
Perfect. All right, and then let's see, as we're looking through this next bit here, and we probably do need some context here, so the top part of the code here. So we've got this other actor here at the top, and again, I'm just noticing we have reg for the shared registers, and then a reg dot write. So again, my object-oriented brain, which needs to be kind of, I guess, initializing here, but I see I have an actor here, and I have bwrite and bread here. So how to think about this here? Should I be thinking about this like, again, my object-oriented brain is going off where I have an actor that has some things that it can do, right? It's writing and doing some potentially mutation on this symbol that's bound to this data structure.
Yeah, eventually. But the interesting distinction here is that doesn't say fun. It says be. So a fun is what you're expecting. It's a function. It's bound to a type, so you can think of it as a method in sort of a more small talky way. But B is a behavior, and that's an asynchronous function. So asynchronous functions are only on actors. You don't have asynchronous functions on regular classes. And while the execution of reg.write is immediate and will immediately flow into the next line of the next reg.write, under the hood, what that actually does is put together a message and queue that message for delivery. Eventually, that actor will get that message. It will get it in causal order. So causal order is enforced by the compiler, and it's not a question of detecting causality violations and erroring. It means that you will absolutely get once and only once causally ordered message delivered, and you don't have to think about it as a programmer. You're just going to get it for cheap. So eventually, it'll get that right message and execute it, but that won't necessarily happen anytime soon. So it depends on the load of your system, how many cores. Right? If you're running on a single core system that's running a single scheduler thread, it literally can't happen until the create behavior for main has completed. But if you're running a multi-core system, it might happen before you even send the next message because it happens to get scheduled real fast. Is that helpful?
Yeah, that makes sense. Now, I guess I have questions about this when you say causally ordered here. Does this mean that is that a sort of language guarantee where I'm going to get this message first because I wrote it first, and then this one, and I don't have to worry about, putting locks in the right order or a handshake between semaphores or something?
Precisely, exactly. And so not only do you get ordered delivery of messages to a single actor, but your causality graph actually goes through that. So, for example, if you have actors A, B, and C, and actor A first sends a message to actor B. Then actor A sends a message to actor C. And as a result of that second message, actor C sends a message to actor B. Now, most languages just say the delivery of the two messages to actor B are unordered. They could happen in any order. Pony does not. Pony says they must be causally ordered, and the message from A must be processed before the message from C. And this has a lot of implications, first of all, on the low-level code in the Pony runtime and how it has to be written, but also in terms of how you can write your program, where in most cases, it means as a programmer, you don't have to think about it. The thing that you wrote is just going to happen, and it's fine. And a lot of the stuff that we do to go, oh no, what happens in this bad situation? You just don't get the bad situation. And you're not even paying a runtime cost for enforcing it. It has to do with the way that message queues are coded. So you're not even paying a cost for it. And you can mostly just say, oh, well, it's going to happen the way I wrote it. Problem solved. Is that, again, I know I keep asking this, but these are deep concepts, and I'm not necessarily explaining them super well. So let me know if it's not helpful.
No, go ahead, Sean.
I was just going to say, it's very easy to get lost in the weeds of this. We could spend an hour on causal messaging easily. More. Yeah.
Well, great, because I'm just I'm the rookie programmer here as far as Pony, so this is great, all this explanations, but that makes sense. And I mean, for me, that's how I want to write my code, right? I just want to write it one line at a time and say, okay, the concurrency stuff, the deadlocking, and I just don't want to worry about it, right? Because then I'm going back to what Sean had mentioned about memorizing 30 different rules, or even 2 rules is too much for me when I'm stressed and trying to build software. So so I love this. I mean, you two let me know if I'm going too slow through this, but because I just think there's a lot of interesting language design. I mean, even just the distinguishment of the keywords here are important things. I mean, are these things that you saw in different languages, or you said, hey, this will be really easy to kind of lint through if we make this distinguishment and provide this sort of annotation here, and kind of give some rule? Or I want to be careful with the word capability, because I think that's going to mean something else.
Yeah, I mean, we use the word capability in so many contexts, it gets a little rough sometimes. In terms of the syntax design, yeah, the syntax design of Pony, there were some, as usual, when you go and do syntax design, a collection of goals simultaneously. One, of course, is to make it as easy to read as possible, but of course, there's no objective function for that. Everybody has a different idea of what easy to read is, and literally nobody's wrong. So it's trying to find some happy medium that we can get by on. And a lot of the decisions we made for that were about visibility at the call site as opposed to visibility at the definition site. Although, interestingly, one of the places that's not true is whether what you're calling is a synchronous or an asynchronous method. And there's a reason for that, but I'll touch on that in a second. So, for example, there's a strong distinction just in the syntax of type names versus variable names. Type names start with a capital letter, variable names don't. Private things start with an underscore, public things don't. There's an attempt not to reuse syntax whenever possible, to have a new syntax for anything that you want to do. So parentheses are not the same thing as square brackets. Angle brackets are mathematical symbols. They are not delimiters. Braces mean lambda, right? They don't mean control flow. So there's a bunch of stuff in there that the intention is to make it as visible as possible where you're looking, as opposed to trying to find somewhere else to look. Now, that's not true with synchronous versus asynchronous method invocation. Why not? Well, it's because a synchronous and an asynchronous method may be subtypes of the same thing. An asynchronous method does return something synchronously. It returns a reference to the receiver. So, for example, reg.write, it actually returns reg. And it means that there's a bunch of places where you have subtypes, and you may intentionally be wanting to not care if this is a synchronous or asynchronous method invocation, and for it to be possible to write a program that doesn't care without having to wrap all of your asynchronous methods and synchronous methods that then go and call the asynchronous methods. Was this a good decision? I don't know. A lot of things are open to discussion.
Well, I'm going to give the more practical helping people, because I've helped far more people, I think, at this point with Pony than Sylvan has. It's a really interesting trade-off, because as an advanced user, I found scenarios where it's incredibly helpful, particularly when writing some tests for esoteric things, to be able to not care about them. Like, immensely powerful. On the other hand, it can be easy for somebody, when they're not paying attention, to trip themselves up, because they'll be like, I wrote A, then B, then C, and they're like, why did B happen after C? And it's, well, A and C were synchronous and B was not. And like, there is a definite trade-off there. And I think this is one of those cases where it's really hard when you're designing language stuff to be like, how much do we favor keeping people when they're starting from making mistakes versus giving a powerful but not going to be used very often feature to people who are really invested in using the language. And in this case, this is very much one where it goes strongly to that rare cases this is going to be incredibly useful to you, where it can definitely trip people up who are not super experienced with the language.
Yeah, but it sounds like it's, a consistent design, which is a good thing. And you mentioned a really important thing, which again, no language is always going to have the perfect amount of trade-offs, in my mind, for every level of, beginner to expert. I think that can be a tricky, balance. I wonder if either of you gotten words of wisdom or had, intense conversations with, Sylvan, you've talked about, working with Simon Peyton Jones and Tony Hoare and stuff. In their respective languages that they've worked on, or, folks you've talked with, Sean, do they have use cases like that where they just say, yep, you just got to pick sometimes this is going to be, a design decision that some people will love or your experts will love, and that's kind of what you pick?
Yes, very much so. I've had many of these conversations with all sorts of absolutely fantastic people. Certainly the people you mentioned, also Don Syme, who did F#, Anders Heilsberg, who did C# and TypeScript, Mads Torgersen, who now owns C#. Guido van Rossum, who did Python, who I'm very lucky just how many of these people also work at Microsoft with me. Not to be too much of a corporate shill there, and getting to work with these folks. I think the specific example I would bring up, and I hope Simon it turns out to be okay with me telling this story, but Simon and I were on a long car ride back from Heathrow to the lab in Cambridge in the UK. And we ended up in traffic, and so we were just chatting for about 3 hours on language design and things in Haskell and things in Pony. And particularly, he was talking about trade-offs between software transactional memory, and the actor model, and where the emphasis is. Where software transactional memory, if you have very little shared state, then perhaps backing out entire transactions and starting over on a conflict is the right choice. If you are more likely to have more opportunities for backing out a transaction, that can become unboundedly computationally expensive and a very bad plan. But funnily enough, the thing he really wanted to talk about was the difference between strict and lazy. Where he said, if you had a chance to do it again, everything would be strict. no default laziness, and make programmers jump through hoops to get lazy computation. Yeah. And that's very interesting for a language that is like Haskell, that is so focused on lazy computation for solving problems, and how people's ideas change over time, and seeing what the benefits and downsides are. And for example, just how much more, I don't know about more, but how successful OCaml and F# are as strict functional languages, or functional first in the case of F#, as opposed to Haskell. I think it's always very interesting to get these perspectives with the fullness of time, as it were.
Yeah, and I'm going to ask both of you guys about languages and evolution towards the end, and how they get adopted. So I'll hold on to that, because I think that's a whole nother interesting conversation, and some of these decisions about choices made sometimes affect that in the design, and well, that's why we keep getting new great languages. So but let's see, so picking up to where we're at here with so we've got our two let's say actors here. We're going to invoke asynchronously these two behaviors here. So they'll happen in order, X and then Y. And then let's see what else we've got here. And then we're going to do a read here. And then, as you've just mentioned, braces mean lambda. So we've got something going out here where we're going to print out our value of X that we return here. And then we're going to print out our value of Y here. And, some of this stuff is, what the types are and so on. But kind of putting this together here, we've got our output here for the environment, which we talked about at the very start here. Now the environment here, again, is out.println, so we're able to change this environment here on the right side, right? So we're writing to some buffer, or...
You're getting real deep real quick here. I like this. So... Sorry, go for it, John. All right. What's actually happening on that first reg.read is very interesting. Read is also asynchronous. And so what we're actually doing is we're saying we're going to pass you a lambda, and you're going to execute that lambda in the context of that actor on receipt. Well, how can we pass you a lambda? We can only pass you a lambda if the things in it are either transferred to you or shared with you. That means they must be safe to transfer to you or safe to share with you. And you'll notice that there's an explicit capture of out, i.e. that's an alias to env.out in that lambda. Why in the world is that safe? It must be because we're clearly using out further on, so we haven't consumed it and given it away. It must be that out is either immutable, which doesn't make a lot of sense if we're printing to it, or it's an actor. In other words, it's a tag capability. It's something that lets you know the identity of something without directly reading it or mutating it. And it turns out references to actors from outside of a behavior are in fact tag references. So this is the standard out actor that's being captured in that Lambda. And this is the introduction thing that we talked about earlier. How do we let shared registers print? Well, we have to introduce it to something it can print to. So that's what's happening in the Lambda. We're not, it doesn't even know it's being introduced to this. It only knows it's being passed to Lambda. But the Lambda has captured that reference. And so when shared registers executes the Lambda, it's going to send another asynchronous message, the print message, out, and eventually it will print. But even more, we're capturing causality here, because that thing that I described of this complicated triangle and why does causal messaging matter? Well, it instantly matters because we now have causal messaging to standard out. And so we're getting in order printing because we've got causal messaging. Instead, normally in a lot of asynchronous environments, when you have asynchronous calls over printing, you get exciting asynchronous results over printing. But here we're leveraging that causal messaging to make sure it always comes out the way we expect it to, without having to do anything. We just write it in order and we get it in order.
Brilliant. My mind is, you're both giving me the aha moment here in the actor model, and that sort of casual ordering here, or causal ordering, excuse me.
That's one that happens all the time. if you read enough of the docs, you'll find things where it says causal, not casual.
And in many ways, Pony is casually causal, or maybe even causally casual. So that's fun.
I love it. Great. Okay, so I mean we've pretty much worked our way through a little bit of a hello world here. I know there's more in this here. I want to just go ahead and see if there's anything else going on in our actor here. Now let's see what was going on here. Now here's okay, so we saw FN here, function.
I'd love to talk about that line. That's an exciting line.
Yeah, let's see what's going on here.
What's going on there?
Well, there's a lot going on there. So first of all, if you look at that function signature over read, val is really important there because it's demanding that the Lambda that you've been passed is immutable. And that's kind of a big deal because you couldn't have been passed it unless it was either isolated or immutable. So it's safe to transfer or safe to share. And in this case, we're saying it's got to be immutable. It can't have state that changes inside the Lambda. Okay, then we go and we say, well, we're going to call that Lambda with this number because the Lambda takes this 64-bit signed number, an I64. Well, how are we getting it? Well, we're looking it up in data based on this name. But if you look at data, it's a map. A map is not a function, it's a partial function. Not all invocations of that collection, of that map collection, are going to result in an answer. So instead of modeling this with exceptions or return codes, Pony expresses partial functions directly in the language, which is to say there's actually a collections.map.apply, and this is using apply sugar so that we don't have to put .apply on there. We just do application over the variable name. We're using that apply sugar to call a function that is in fact partial. That is, there are some elements of the domain for which there is no answer. There is no result to return in the range. And so instead of saying we're going to create a new kind of result, which is an exception or anything like this, we say it's literally a partial function. You get nothing. And the way that we deal with that is, first of all, we have this call site visibility where it's got a question mark on it. And that means I'm calling a partial function. And the compiler knows damn well it's a partial function before you told it. So it will complain if you don't put the question mark on if it's partial. And it says, okay, great, you might get nothing back. And that's what try is. And that's the part that looks a bit like an exception handler. But you'll notice there's no catch because there's no value coming back. There's only attempt this. If that's not possible, if this is a partial function call for which there's no answer, well, then you have to execute the else branch. And here the else branch is 0. So we've got a default value effectively of 0 for this read. Now, talk about getting in the weeds quick. That gets into the entire error handling philosophy of Pony, which is a bit on the different side.
Interestingly, the that question mark there was not there when I first started using Pony, when Sylvan introduced it to me, and that was slightly contentious when it went in. And there's a very practical reason for it, which is that the compiler will not allow you to call a thing which is partial without putting that on there now, because what could end up happening is that people would often write a try where they wanted to do multiple things within it in order to handle a partial thing, and a thing might become partial later. And before the compiler was actually checking this for you, it was possible to basically eat things that you weren't expecting to for partial things. And so it's an interesting trade-off there. The compiler doesn't actually need this. This is purely for protection of people who write their code in a certain way. You could if you wrap every single one of your partial things in its own try, you wouldn't need that. But there was a lot of discussion about, is this addition and this small bit of annoyance for people who don't write code this way worth it for people who write code this way? And I think the big thing that it came down to is most people, even though we tell them this is not an exception, are still going to write this code like they write exception handlers and other things. And we feel that this trade-off for a little bit of extra pain for people who don't write code this way is worth it to protect an awful lot of people from something that they're simply not going to know. We can say you need to read the tutorial, and the tutorial says, please read this through, but almost nobody, even who's been using Pony for a year, actually recognizes that these are not exceptions and that there's a difference. And we felt like this is a thing where we need to protect people from themselves, because there's already so much for people to absorb.
And just sort of harping on that, nothing's perfect for everybody. Sebastian Blessing is another one of the Pony language developers. He hates this thing. He hates that question mark. So opinions vary. I think in the end, Sean's point of view, well, many people's point of view, it gives visibility when you have a change in a try block, so that you minimize surprise. I think that's a powerful motivation. But nothing's 100%.
Yeah, but it's a great way. I mean, like you said too, minimizing surprise when you're deep in debugging something, and especially if it's a language designed for concurrency, although it's giving you lots of nice guarantees. Again, it's handling debugging code, I guess, is sort of interesting, which, I mean, I'm happy to talk about maybe briefly, because I'm kind of curious about the philosophy for handling errors. Some languages return codes, some return exceptions, and you're supposed to handle those. Some languages, I'm sort of thinking about Erlang, just crash, right? And that sort of crash and restart or something might be acceptable. So I mean, maybe just again a basic question. I mean, is this sort of a main mechanism, like return nothing and then just kind of keep running along? Error codes, what's the sort of philosophy in Pony?
Yeah, I mean, Pony's really built entirely around partial functions for error handling. There's really no other approach to it. Don't get me wrong, you might write a standard library such that you return alternate values, because Pony also uses an algebraic type system. So it has both union and intersection types. So you can make that a union return. Or you could, build in default return values for things. But as soon as you do that, you're starting to push up the handling to another level. So you're saying it is the responsibility of the caller to be certain about the results of the call. Sometimes that's the right decision. Sometimes that's the wrong decision. But it really just comes down to the partial functions and algebraic types. Either you want to back out as fast as possible to the origin, or you want to give many opportunities for examining the cause and examining the different possible return values. And that would be more like using a union type, whereas the first case of back out as fast as possible is use a partial function, get out of here as fast as possible. It's actually, so I'm going to harp on our own language a little bit here in that. So I'm a huge Smalltalk fan, and Sean is as well. And honestly, I prefer the way Smalltalk does non-local returns as an error handling mechanism. It's,
oh my God.
Yeah, it's just beautiful. At this point, would I instead design a mechanism? Would I jump through hell and high water to get an efficient compiled form of non-local returns? Yes. Partial functions was really intended as an attempt to get as close to non-local returns as possible. But what it ended up doing is pushing responsibility for that up to the caller. And that kind of is unfortunate. It's better to be able to say, no, at the point where I'm returning, I need to be able to say this is a non-local return, but it's got a value, but it's not exceptional, because exceptional paths are rarely all that exceptional. And I think the possibility of building out something that was a highly efficient native code version of non-local returns is very exciting. Let's call that an open research problem.
Yeah, excellent. All right, well, I'm going to do a little bit more research on Smalltalk. Seemed to be one of those languages that had a lot of different programming concepts tried out early on. I mean, it's inspired a lot of the object-oriented stuff, I guess, and message passing, which is what I try to remind folks is a key tenet of object-oriented programming that gets forgotten. And how I think about, well, again, with my model, actors, which I'm trying to deprogram here. Let's see. So I think we've worked through most of this example here. There is a little bit more, and as I'm reading through this, and I'd encourage for folks who are watching this to actually, try this example out in Compiler Explorer, or download Pony and try it out here, because this is a pretty cool example here. Is there anything else I should show here before we hop back into some questions and talking about Pony and where it's used? Any example that a user must see from the patterns book here?
I don't think there are any that are must see. No, I mean it's a collection of things of how do I do X, Y, Z type thing, where some of those are just generally every single one of these things is something where we ended up helping people multiple times, right? And we're like, here's how you go about doing that. Here's how you would do mix-ins if you want to do mix-ins. This is highly deep and weird abuse of the facilities that are in the language, but here you go. You can do this, right? We don't want to cover this now. This has got to take way too long to get through for all of the additional background on it. But and there's a variety of them. Some of them are really simple, like notifier is a very simple one. It's basically, hey, here's a callback pattern, which is regularly used for specializing actors, right? If you need to do specialization in a different kind of way, you might want to use, mixin. There's just a variety of interesting ones. The one that I would say, if we were going to do, that would be to look at waiting. Because of how the runtime works, you can't say, well, you can have an actor do a call into C to go, I'm going to sleep now. But you will mess with the runtime if you do that, right? So this is one where it's an example of, we're going to create an actor, which is a timer, and it will periodically do something over a period of time. And if you want to wait, what you actually do is you start an actor whose responsibility is to tell you every now and then to do something, whatever that is. You want to wait, you don't sleep, you go ahead and you do nothing, but you have a timer which tells you, say, every 5 seconds, do thing, where it sends you a message for what to do.
I love this. Oh, go ahead.
This is sort of a repeat of, in a weird way, of what we were talking about with environments, where interaction with the outside world, the things that are not adding numbers together, input, output, time, are all done via actors themselves. And it's a little bit of a different way to look at things, where much like you use monads and strict functional language, strict and or pure functional languages to encapsulate things. In some sense, that's what's happening with interaction with the outside world by using actors to encapsulate input, and output, and time, and physical devices like keyboards and things like this.
Yeah. Well, a thing that an awful lot of people come in to Pony with is they have the impression that the actor model and actors are about concurrency and parallelism, and they basically want to do a fork join type thing, right? I have a big array and I want to divide it up amongst a bunch of actors and have them do some work. Yay, right? It's a concurrency thing. And for a lot of people, it takes a while for them to understand actors aren't really about concurrency and parallelism. That's just the side effect of things. It's really they're units of synchronization, right? Or units of protection, right? Like here is an actor which synchronizes access to standard out, right? Only through this actor can you get access to it. Now, because there is this synchronization through an actor, I don't need to have a lock, for example, because we are synchronizing through the actor and by sending messages to its queue, etc. And that's a thing that most people don't get about the actor model. And if I wanted anybody to ever take anything away for one thing, if they don't know anything about the actor model, it's that's what actors really are. Much more is units of synchronization.
Excellent. Love it. I mean, thinking about synchronization, we've mentioned this word several times, so maybe it's time to bring it up in safety. And I think I see parts of it here, so that's why I'm going to leave this up for a second. But we've talked about the reference capabilities, and that's a key part of the safety of the language, as I understand. And for synchronizing things, right, if we have them. So I do notice a new keyword here. A few new keywords here. I see ISO, ref, let, which we've seen, which at least ref and let with my other languages mean something to me about can I change something or immutability or bind this one time. ISO is a new one though for me. So does that have to deal with the sort of capabilities here about what I can do with crate here versus what I can do with next here?
You bet it does. That's exactly right. So Pony has 6 capabilities. One, arguably 2 of which I wish I'd left out of the language, but we can talk about that. But really, these capabilities, I'm going to go straight to deny versus rely guarantee reasoning. These capabilities aren't fundamentally about what you can do with them, because actually capabilities are a viewpoint. This isn't about what the thing is, but about how you see it. And indeed, you can look through multiple capabilities and arrive at some other capability. That's called viewpoint adaptation, where if I have a val reference to something, and inside that object, which is immutable, inside that object, there's a field, which is a reference to something, which is a mutable reference. When I look at this thing, when I look at the field inside that object, I see a val. Because I've adapted my viewpoint through the lens of this origin object through its field. And so the capabilities that exist really just arise out of the math of what is visibly locally and what is visibly globally. And so backing away from deny capabilities and trying to give a rely view now, and then we can see how it maps. ISO is about external uniqueness. In other words, it's a bubble of memory. It's isolated. There's one and only one of these things. Now, inside of that region, it might all be a complex graph and even point back at that entry point object. That's okay, no problem. Sorry, go.
I'm going to correct your language, Sylvan, right? That happens rarely, but it happens sometimes. What's important with ISO is that there's only one alias. Not
Yes.
that there's not that there's one, but there's one alias to it.
Good. Yes, that's important. So there's that concept of a bubble, or nowadays I would call it a region. There's an isolated region of memory, and this ISO capability lets you know that you're looking, as Sean says, at the unique external alias that gives you a path into this thing. Now, that doesn't mean some other function call doesn't see this as a normal ref, which is a normal mutable object, right? A Java or C# like object. It might, because it's all about viewpoints. So we might make a function call where we've changed which region we're operating in some sense, and we're going to go and treat this thing as a ref. That's fantastic. Val is about immutability, and immutability not in a const-like way, as in I can't change this right now, because that exists in Pony. That we call that box. That's something where we don't know what it is, but we're not going to touch it. Val instead is a global promise. This thing is immutable. It's immutable everywhere, and it's immutable forever. There's no future state at which something becomes mutable. It's simply immutable. And what you're looking at here in that annotation, I love that you've highlighted this, because those reference capabilities are being used in two different ways over a constructor as opposed to a function. So that constructor is saying it's going to return you an isolated object from the constructor. It says, since everything you passed into this function, into this constructor, was either isolated or immutable, it's safe for me to pass back something that is, we know for a fact, is a unique alias. Whereas on the function, what that ref is saying is the receiver is ref. It's a normal reference, a Java-like mutable reference. And therefore, you'll notice it's saying counter equals counter plus one. Well, because we have implicit this in Pony, that means what you're really saying there is the field counter on the receiver, we're going to add one to it and actually store the result. Well, we couldn't store the result if this thing was immutable. So we have to demand that it's a ref in order to be able to call the function at all.
Very cool. Okay, so I should think about these. I mean, immediately a few things came to mind. One, I thought about these reference capabilities almost like permissions on a file or something. Read, write, and execute. But we've got some sort of set of things here. And the other was when Sean said the phrase unique alias, and then I thought unique pointer, and then I thought about move semantics, and then I thought about borrowing and sort of Rust stuff for the safety. So let me kind of unshare this screen, and maybe we can talk about influence of language and a little bit on the safety side here, because and the guarantees that Pony gets us here. So I think this is really interesting, and hopefully other folks are going to try once they learn about a safe, highly concurrent, general purpose, object-oriented language. So what can we sort of say about guarantees the language gets from the reference capabilities? Are they similar? Should folks think about it like Rust to pick a language at like compile time?
It's really, Rust relies on pre-structured memory. So in order to write safe Rust, you must be using only tree-structured memory full stop, which means you cannot have an object graph. You cannot have normal data structures. You can't have, for example, a hash map. Cannot be done in safe Rust because it is not, strictly speaking, tree-structured memory. And it uses the borrow checker to enforce this and to enforce aspects of immutability that, funnily enough, are not actually this is just my crappy opinion, so talk to Rust people to get a better opinion, but are much more about prompt deallocation and not needing a garbage collector, but instead allowing for prompt deallocation, because you can track exactly when something goes out of scope, so you don't need a garbage collector. This is just a very different focus from Pony. Pony has a garbage collector and is perfectly happy to use it. It's a perhaps very different design for a garbage collector than some of the stuff you may be used to, in that because of the way regions are structured, each region can be independently garbage collected. So when you have an ISO, it's also giving you a concept of independent garbage collection. Now, that's not as strongly leveraged in the Pony runtime as I would like it to be, but it does mean that at least at the actor level, all memory in an actor can be completely independently garbage collected from any other actor. So actors are fully independently collected, but it's on this basis of region-like memory management. And indeed, even when you share stuff, it uses a protocol for exchanging deferred, distributed, weighted reference counts over immutable things and over actors themselves, even to do garbage collection. Well, why am I telling you all this as compared to Rust? It's because it means that the problems we're trying to solve in Pony are quite different. It's about safety, even in the presence of complex data structures and concurrency. Whereas Rust is saying complex data structures and concurrency are not our problem. If you go write that in unsafe Rust, or in C in some cases, right, when you're doing asynchronicity and plugging that in as an async provider. And it's your problem. You can use Rust to give it what you believe is a safe interface if people call it in a safe way. But the thing itself is not safe. It's unsafe. There's unsafe all over the Rust standard libraries, and for good reason. It's because they're looking at a fundamentally different set of properties that they're trying to enforce. So backing that out a bit, what Pony is trying to give you is no unsafety that exits the runtime. There isn't a way to write unsafe Pony. It just doesn't exist. All of the things that could be dangerous are inside the runtime. And the idea is that means that you're never going and adding new sources of unsafety. You're leveraging this mostly done runtime, nothing's ever done, to get your properties surfaced out in front of you. And that it's not just providing memory safety, it's providing that concurrent and asynchronous environment as well. And that it's providing it in a way in which all data races and all deadlocks are ruled out by design. It's literally by construction. You can't have them. Now, I feel like I have to say, if you include FFI in your program and you go call FFI, good luck. Pony isn't providing you like a separate process or a sandboxing model for your FFI. You can use a sandboxing model inside your FFI. I highly suggest that people do. There's some better and better sandboxing models that you can use for FFI, or even gvisor, right? You can use anything you want under the hood there to do that. So there's that capability to shoot yourself in the foot. Don't do that. Stay away from FFI. But if you're writing Pony, you're working within this environment that is theoretically giving you all of the tools you need to write your program already. You're not having to go and invent the new tools. But again, because we're willing to take certain hits, like doing garbage collection, Rust doesn't want to do that. So I feel like a lot of times people look at languages to which is better. I don't have a lot of value on that. Things are designed for different purposes. Most people out there, the language they should probably be using is Python. That's probably what they're looking for. And only in some cases should people be looking at other things because they have other needs and they need different sets of guarantees and properties.
Yeah,
Sean, is there any stuff you want to capture about properties that Pony wants to give you?
No, I think that was very good.
All right, cool.
Yeah, I think that's an excellent, it's impossible, I think, to pit two languages against each other. As you said, it's always different trade-offs, and it's a religious thing.
Somehow we understand this over human languages. Like no one tries to tell me that French is better than German, right? Well,
Yeah.
mostly.
But
Uh,
you not been to Quebec lately?
yeah, fair enough. But just in general, in human language, we sort of have a pretty good understanding that there are different ways of communicating, and it's kind of neat that you have a tendency to certain kinds of formulation of thought in different languages. It's just really neat. And in computer languages, we seem to lose that perspective and have a much more, I think, frankly, a much more naive view of language, which is unfortunate.
Yeah, because in my mind, I'm already thinking it's like, well, for any highly concurrent system where I don't want deadlocks and data races, I should write that part in Pony, and then I'll figure out how to marshal the data or send it over, potentially through FFI, doing things
Sure.
properly, and use a mix of tools, and that sounds great. I'm ready to dive in more. But with that in mind, I mean, are there other languages, and maybe I'll throw this to you, Sean, first, actually, that you think could influence Pony in the sort of the design direction? Or, I mean, maybe it's even just like standard library stuff where like, oh, they have it, and that would be nice if we brought that in.
You should go on to another question. I don't know. I'm going to come up with an answer to that right now. I mean,
Oh,
there,
I'll
there are
dive
certain,
in.
go for it.
Well, I mean, I'll just open with every language needs to be learning from F sharp. There's no language out there that can't learn something from F sharp. I'm not saying F sharp is perfect by any stretch of the imagination, but it's an incredibly interesting and powerful environment that is, well, I mean, here's a concrete explanation. Sean's doing a project in his real job. He needed the right tool for the job. Did he pick Pony? No, he picked F sharp. There are reasons for this, right? I think in a very different vein, I think there are also some big open research questions right now. So, spoiler, I work as a researcher at Microsoft, and we have language projects going right now. And I think one of the things I described earlier is this idea of an actor sending a message to a collection of actors and being able to take action. The reason I mention it is that it's fundamental to certain kinds of programs, particularly databases. It turns out the actor model is just not an awesome fit for databases. You end up writing your own asynchronous transactional locks over the actor model, and it's not efficient. What other kinds of things can we do? So there's a research project we're working on there. Could that stuff flow back into Pony? Yeah, it probably could. I don't know. We'll see. I think in another vein, there's a bunch of work on mixing memory management strategies within a language. For example, work in .NET to try and do arena-based allocation, or work in various garbage collected languages to find places where you can remove the garbage collector and rely on some other mechanism, whether that's reference counting or some other mechanism, and for performance reasons. And I think that's incredibly interesting. That's also something that we're doing research on. And then, could that flow back into Pony? I mean, that would be awesome. I don't know. And I think another place is heterogeneous hardware. And unfortunately, these days, a lot of times what people mean by heterogeneous hardware is running on GPUs. But I don't just mean running on GPUs. There's a lot more interesting stuff happening. Even if it's things like big little cores on ARM devices and understanding what that means from a scheduling perspective. But, GPUs matter too, or they do right now. We'll see what happens. And that kind of heterogeneous environment also rears its head in heterogeneous memory. What does it mean in the presence of non-volatile memory to have a program? What does it mean in the presence of non-local memory like CXL to have a program? And I think there's a bunch of stuff we could learn from where the approaches that Pony takes. The reason I'm mentioning these specific things is a lot of stuff that Pony does over how it it provides a concurrent data race free environment, are an excellent foundation on which to build other things that are incredibly hard in the presence of data races and concurrency problems.
Yeah, I think one of the things for that's interesting is in a lot of cases it's like, well, what might you want to take from other languages? And I have a hard time answering that because it's like, well, what is the problem that somebody's trying to solve? And what's the right way to solve it on the basis of what Pony is doing, right? Like it was I can't remember what it was. Oh, right. It was when I was learning Ruby, right? I was like, oh, Ruby has a lot of stuff I really like from Smalltalk. This is nice, right? And oh, look, it's got some of the stuff that I like from Perl and everything. And this was fairly early on when I was learning Ruby. I think this was like 2000, 2001, something like that, definitely pre-Rails. And the thing I came to realize though was that like it took a number of features that I liked from different languages, but they intersected in weird edge casey ways at points, right? And so I have a hard time with what would you want to take from language? Boom. I'm like, I want to take inspiration from them for things they're good at that perhaps like if you could do that in a concurrent way and with the stuff that Pony gives you, you'd want to do. But for an actual individual thing, I don't know, because how is it going to interact with everything else in the system, right? Like, there's all sorts of stuff that went into LiveScript, which became JavaScript, which ECMAScript, where it's like, those are some of my favorite things from like, from Scheme and hey, I'm an awful person. I actually like dynamic scoping. Clearly there's something wrong with me, right? But you start putting a number of these things together in like LiveScript, and I was like, oh God, this is so easy to shoot myself in the foot, So I very much I'm very wary of just being like, oh, well, X does that, so Y should do that too. It's like, now you gotta, for lack of a better word right now, you have to look at like how it all comes together. You have to look at it holistically within a language. And sometimes I think you just have to say, we're not going to do that, even though that would be nice, because it just creates areas where it's easy to blow your foot off over here, right? Which is not the way that every language goes about doing things. I think of C++, which really seems to want to be a toolbox to do whatever it is that you want to do. And God bless you if you understand it all and can figure out how all the parts come together. I've never been able to.
So I love the way you put that, Sean, because this is exactly why we don't have non-local returns in Pony yet. It's the scope escape problem. Like Smalltalk people don't realize Smalltalk has problems, surprisingly. One of them is non-local returns escaping scope, and then you try and deal with a non-local return and your program explodes in a completely unrecoverable way. And you're just doomed, possibly forever, because your image is trashed, right? We can't have that in Pony. We can't have that lack of safety over a return value. I mean, we're not going to do it. So that fits in exactly. Sorry, I'm pointing on my screen to where Sean is, but it fits into what Sean is saying about it has to fit together holistically. It has to make sense within this environment, even if it's awesome, like non-local returns. We might not be able to do it because we're not hitting our getting stuff done design philosophy.
Yeah, I love that. The discipline, creating a vision and not just grabbing whatever is flashy, and seeing how things fit is really important. I mean, as we were thinking about or talking through some of these, examples and features, I was just realizing that a lot of it seems like, way at the start when we started the conversation, Pony gets a lot of its performance, even though it's because it's efficiently able to garbage collect and not stop the world. And, so that sounds like a great thing. And I just wanted to ask, because I, as a programmer, actually love garbage collection, and I'm in, the wrong sphere of like game development where everybody hates it. So I was just going to throw the question to you guys. Why are folks adversarial against garbage collection so much? Do you have an answer? Oh yeah, we should be careful.
So I'm willing to jump in. It's performance and it's non-predictability of performance. That if I'm video games is such a great example, right? Because video games are, there's a reason so many financial industry programmers are former video game programmers. It's because there's this need for not just high performance, but consistent high performance no matter what happens. And if you have the dreaded 7-second pause on your JVM's garbage collector and everything stops for 7 seconds, as clearly it's not really 7 seconds anymore, it depends on your application. But if everything comes to a screeching halt and you cannot predict why or when this is going to happen, for many use cases, this is just full stop. You cannot do this. And you have to find some other way to cope. And you get folks who jump through hell and high water using the JVM and .NET to strip out things that could cause garbage collectors, use statically allocated memory, like do all these things to fight against their own execution environment because they can't afford the unpredictability. And it's not just in your mutator performance, mutator performance in the sense of the thing that's executing as opposed to your garbage collection threads. Mutator performance matters too, but that's something that Azul systems spotted early on, which is that actually, if you degrade the mutator performance in order to eliminate unpredictability, that's often a huge win for programmers. They would rather take a steady 15% performance hit than an unpredictable hit. And I think there were some approaches to garbage collection that really left scars on people. I think the video game industry trying to use the Hans Bohm collector in the 90s over C and C++ code basically created a bias against garbage collection that has lasted for the last 20, 25 years. And for good reason. The Hans Bohm collector is awful. I mean, it's brilliant research. Do not use this in production. It's just abysmal. But at the same time, people don't realize that almost everything they do uses garbage collected code because the sheer quantity of JavaScript and especially TypeScript that's out there right now is mind-numbing, much less Python, which of course is garbage collected as well. Now it's reference counted with the cycle detector. That's still garbage collection. And almost everything you do is garbage collected. And we're down to, it's really these niche industries that are saying, I can't afford the unpredictability. It just happens that those niche industries are unbelievably important and quite a bit of fun.
So I want to go for the different angle of this, but I agree with everything that Sylvan said, right? Which is that I don't think most people, when they say garbage collection, are being even vaguely precise at all, right? Like an awful lot of people mean stop the world, a particular strategy for garbage collection. But I've had this conversation so many times with people who are like, now that Rust has proven you don't need a garbage collector, and as a beginning of a statement. And I get very stroppy. I try not to get stroppy with people, but that one gets me really stroppy. Because like when people make statements like that, I think, oh, so you haven't done much real memory management, have you ever? Right? Because I mean, going to the OS and getting memory in a regular one is an expensive operation. So most people try to like cut down on the cost of that. So they build allocators, and now the allocator, you need to return stuff to the allocator, and the allocator has to manage all of this memory. And at least as far as I'm concerned, and the strategies for how you go about that is garbage collection. You're deciding there is something which is not specifically you deciding when things get freed, et cetera, and everything. And it becomes a question of what is your strategy and what are the trade-offs of your strategy. Stop the world is very simple in terms of what it does, with some really horrendous like side effects for people if they care about predictability. But I mean, there are so many other things. I mean, Sylvan said reference counting. Lots of people are like, that's not garbage collection. I'm like, I'm sorry, that's garbage collection. Literally anything where you yourself are not freeing the memory is garbage collection in my mind. So it really becomes, what are we talking about when we talk about garbage collection? There's a friend of Sylvan's mine, Andy Turley, who loves like every different kind of garbage collection. You can talk about them endlessly, and he's just like he's like one of those people who's just like, yeah, no, that's garbage collection, and no, that's garbage collection too, yeah, that's garbage collection. It's yeah. I mean, so I think
he's encyclopedic. Also, I'm totally gonna shamelessly shout out the memory allocator that came out of the Pony project. So there's a general purpose drop-in malloc free replacement called SN malloc. It's on GitHub, Microsoft/SN malloc. that very much is built on the techniques that go into the Pony runtime, but as a drop-in memory allocator for your underlying memory problems, exactly as Sean was talking about. And actually works great with Rust. So if you need an allocator to generally improve your performance and handle very complex multi-threaded allocation issues, it literally came out of Pony in the way Pony's message queues and memory management works.
Yeah. What, Eddie, I started using Pony because we had need for something like Pony, right, at a startup that I was at. And we decided rather than writing our own runtime in something, we were going to go ahead and leverage the work that Sylvan had already done for that, and then we would build on top of it and make additions to it, et cetera, and everything. And we had a thing that we ran constantly all the time where we just maxed out like the data that we could shove over a pipe into like an application as we were developing it to test for every little thing to go, do we degrade the performance at all? And one of the things I loved watching about this was that we had a nice little chart which showed like what our latencies were for everything. And the friggin' thing was flat all the time. It's garbage collected, but it was just flat as long as the data that we were sticking in was more or less the same shape and coming at the same rate. There was never any garbage collection pause or anything like that because of how the garbage collection is done in Pony. Like to an extent of like, this is like Azul's garbage collector is great, right? But it's still like, it's within the JVM and it's still got like some jitter and everything for that, where we tried using like a JVM type one for that. But just that, like, yes, I'm doing garbage collection. It is saving me a ton of time. I don't have to think about it when I'm writing my application code. But my trade-off in the case of Pony, the trade-off for the most part is you're losing some throughput, right? And there are some topologies of things where that level of throughput that you're losing is going to rise, right? But you're losing some throughput. In return, though, you get you're going to get a nice predictable latency that you don't get with something like, you know, the standard stop the world garbage collector like the JVM shipped with for a long time. I feel like I read something like they were shipping with Shenandoah now, so that might not be the case, but I'm not sure if that's actually the case or not.
Yeah, very, very cool. Yeah, and I'm with both you on the, you know, I point to game programmers a lot to say, hey, that object in Unreal Engine, which everyone uses, is reference counted, and that's like, you know. So, but I think you both hit the nail on the head with the trade-offs here, and I'm glad we're able to capture that. So now I can just point to all my friends like, listen, it's not just me. So leading into some of our final questions here about Pony, where is it being used? Do you know of use cases? I mean, I found somebody had a startup. I think Wallaroo it was called.
I was there. I was part of the team that picked the usage, and then around the time that company pivoted to doing different stuff, I left, and they built a new product. The product that we built did not get marketplace traction to a level that was needed. They built a new product and they moved on to using a different language for that. Right. So I know of like a few like things where people were using it for work, not in like this is officially adopted in their type thing. People have from time to time come into the Pony community with interesting things where they're recruiters, et cetera, and everything. But like what usage there might be, I don't really know. Like the fact that, wait, what's that like CIA equivalent that the UK has? Is that THC or something? What is that, Sylvan?
You mean NSA, but GCHQ.
Yeah, GCHQ. The person who said they were recruiting for GCHQ, who came in like a few times, that was an interesting thing. There was somebody from in the National Health Service, the NHS, came in, a recruiter from that one time. There was somebody who came in from a firewall company that said that they were using it in a like firewall type appliance. But I mean, I don't really know. Like. It is ramp up time to be able to use Pony is rather high for a lot of people. If you have a background in doing concurrent programming and you've seg-faulted your way into like enlightenment, then most of what's going on in Pony is going to make a lot of sense to you right away. But an awful lot of people come in and don't really understand the value at some type of deep level, and they don't have the background where there's an awful lot of like hard getting over the top on that, which, you know, is limiting to a community. There's that, is this a tool for beginners or is this a tool for experts? Tools for experts generally don't have anywhere near as much usage. And Pony is a tool for experts that is not built by a large corporation. Like, I've had people ask me before, what's the best way to make a programming language popular? And I say, well, maybe have like Google or Microsoft or somebody support it. That would get you an awful long way along. It's not guaranteed, right? Like F# is not in the top 10 in the TOB or whatever, but it's got Microsoft behind it. Ruby never had that. It had the, look, Rails, right? But yeah, I mean, there are inklings that are people using it. I don't know what they are, but if any of those people who are using it see this and are like, we wish Pony could do X, they should come talk to us because we'd be happy to hear about it and perhaps try to build it in or accept their contributions.
I guess I've got a follow-up. That was nicely put, especially about the language popularity, competition that folks try to sell. Why is it that for either of you, you think there is sort of this fear? I mean, this is what I want folks, this is my hope for the programming world, if I can leave a legacy, that people just use the right tool for the right job. But why is there this sort of fear of adopting a language that might make them 10 times more competitive, right? If Pony's clearly, better for doing this task. Is it the expert bar? I mean, you guys tell me your opinion.
Well, I'll give you an opinion. I have many opinions on the subject, and ask me again in 5 minutes, and I might give you a different one. But one of them is that being conservative about tool choice is really about risk analysis, and it is when you're doing risk analysis, you need some level of expertise in a subject to understand what the risk is. If you don't have that expertise, you have to be able to delegate that risk analysis either implicitly or explicitly to someone who has the expertise. So the most common thing to do when it comes to anything to do with programming, which is generally speaking, the risk analysis is well outside of people's capabilities, is to implicitly delegate based on what your competitors or market peers are already doing. And this leads to a tendency to do what is already being done and to accept the problems that exist in order to avoid an obvious risk analysis failure, where it's not even a question of, oh, but you could do better. It's how could they know that they could do better? They're not in a position to know that. And I think it's quite rational. I think anyone that goes and says, oh, how can you be so dumb? The usual thing, right? You're just not understanding what these people's constraints are. If someone is going out and building Walmart's backend, right? Their job is to make billions of dollars on supply chain management for Walmart. They are probably absolute experts on supply chain management for Walmart. That doesn't mean they're absolute experts on picking programming languages and compilers and things like this. And so something needs to get delegated. Some amount of risk analysis has to get delegated.
I think part of it as well is that the way that people go about like making those decisions is like it is looking for safety in numbers in a lot of ways, right? Like nobody's going to get fired for pick and go, right? Like you might run into tons of trouble for your particular project using Go, right? Or whatever language it is that you pick, right? Whatever tools it is, it's not just the language, it's so many things, right? Where you could end up having a problem that like you're just but it's hey, I picked Go and lots of people use Go and so there we go.
Sean and I worked on a project in Go where Sean bore the brunt of this, so this has some very personal meaning.
I've worked with things in Go before, and where it's like Go is a good fit for this, and Go is not really a good fit for this, and that particular one, it was like Go is not really a good fit for this, but that's neither here nor there. But it's like I think if you had enough knowledge, you could sit down and go, what is the problem that I'm trying to solve? And what are the hard parts about that problem as best that I know it? And then you could pick a tool where a programming language is part of the tool, but your tool is actually a collection of many things. It's not just the language and what it gives you. It's the availability of libraries and so many of these other things. But like, it's really hard to be able to actually know what that is, particularly because a lot of people don't really necessarily know what they're building when they set out. Like they don't have a really good idea for it. And most people work at places where if you get something wrong, you can't go back and start over. People think that if you've done 6 months of work and you realize that you're at a dead end, that starting over, they don't realize that starting over is probably actually the quickest way to get to a good place instead of trying to muddle through what you've created. And when most people operate in environments like that, right, then picking the thing that everybody else is using, right, is a reasonable choice to make, right? If you're operating in those environments. Like I know there's like, it's like in the Hacker News community and everything, Paul Graham, like years ago, got people talking about the Blub programmer or whatever, like, but I don't know, that just strikes me as elitist crap. And that like, really what it should be is like, you got to put yourselves in the shoes of who the people are who are making that decisions, and what is the thing which is in their best interest. And in their best interest for them probably isn't pick the best tool for this job, right? It is pick the tool which is going to maintain my getting paid, right? And there are so many factors that go into that. And you know what? If you fail and you used Go at this point in time, that is way better for your career and for your job than if you picked Haskell and you failed, or if you picked Pony and you failed, or if you picked F# or Elixir. Pick a language which is not particularly well used. If you picked it and you failed, regardless of the language that you used, that's going to look much worse than if you were like, hey, we used Ruby and we failed. Oh, well, at least you didn't, at least it wasn't a bad choice that you made there with the picking of the tool.
Yeah, interesting. Yeah. I think spot on, and just the many factors that go into this. I recently, for instance, started teaching instead of C++ the D programming language, which was, again, sort of going through a little bit of a risk analysis of it's not too different. So folks, if they go do Java or C++, they can learn it. But it's been a controversial decision. And just because it's not the regular thing, or if I disappear, right, are they going to pick up, another instructor that'll teach it this way or whatever? So touching on a few interesting things. I did see in one of the last Week in Ponies that there is a course, somebody is teaching apparently an operating systems course in Pony. I don't know if you two knew about that, but I dug through the forums and yeah.
Yes. One of the University of Florida's. I tracked it down to that based on the class name. Yes, a whole bunch of them showed up in the beginning of the fall, in our Zulip community, in the beginner channel, beginners help channel, and I had a side conversation with someone where I was like, I really feel like I'm being asked to do all these people's homework, and then it turned out I was actually kind of being asked to do these people's homework. It was a great moment, but like once it became clear that these are the story was that there was a professor who was like, oh yes, Pony actor model, great for doing this distributed systems thing we're doing.
Mm-hmm.
You incoming CS students, not only should you learn all of this distributed system stuff, which is new to you, but you should learn this programming language that you're not familiar with at all. And like with that background, I felt much more willing to help these people than I did beforehand, when it was just random people coming in and being like, give me the answer. And I was like, oh, I see. You have class assignments that are due, and you're not being asked to learn one new thing. You're being asked to learn two entirely new things. Ouch.
Yeah, well, I'm sure those students are eternally grateful to you. But I think it was interesting. And again, that's going to be a whole nother discussion on teaching and learning that we could have another 2 hours about. But I want to definitely revisit that if we're able. But I want to give us a little bit of a rapid fire questions as we wrap things up here. So I'm going to ask 4 or 5 questions. I'm going to ask them. Sean, you get to go first, and then Sylvan, the same question after. Just first thing that comes to your mind, a sentence or two. You guys ready?
Oh, yeah, okay.
All right. So what's a programming book, video article that you've read that you think every other programmer should read?
Trash Day. It's a paper. It's about how they improve the performance in a series of clustered an application which is running on multiple different JVMs by synchronizing the Stop the World garbage collection amongst all of the nodes at one time in order to improve throughput.
Excellent. Same to you, Sylvan.
Deny guarantee reasoning is paper. I think it might have been a Popple paper. I have to look it up. Matt Parkinson's on that paper. It will fundamentally change the way that you think about the guarantees that you want in a program, regardless of language or anything like that.
That's a great paper. I love that paper.
Excellent. Next question. A word of advice to young programmers just getting started.
You're going to have to work hard if you really want to get good at this.
Have something that you want the computer to do. You can't just learn programming. You have to learn how to do a thing. And in the old days, we all learned it doing video games, but honestly, that's too hard now. People think that they want to do video games, and they think they're gonna write Call of Duty. Don't do that. Load Runner would be a better start. Even that's kind of hard. But just have something you want the computer to do that you're motivated, that seems fun, where if you got a result, it would be exciting.
Next question. Favorite game or board game?
Oh, well, I mean, if we're going to... Okay, I'm not going to go by hours played. There's a video game called Timberborn, which is a city builder. I was introduced to the term city builder when I started playing Timberborn. And basically, it's a city builder, but you're controlling beavers.
Sylvan, a favorite game or board game?
For a complex game, one of my current favorites right now is Terraforming Mars. That's super fun board game. I think Azul, which is a very simple board game, but is collections and pattern matching and stuff, that's really nice as well. I tend to pick board games. For computer games right now, honestly, I play what's on Game Pass because, it's there on Xbox and my employer gives me access. Stalker 2. Play Stalker 2. Mm-hmm. Make sure Ukraine gets the money they need.
Love it. Backgammon. Everybody should play backgammon. I love backgammon.
Perfect. Great answers. And we might have touched on this, but first time you saw something on a computer and went, wow.
Well, we actually had a conversation about this beforehand because you sent this question ahead of time. Um, I could only really think of one of those, which was grounded in the my experience at that point with using like DOS, Windows, etc., and everything. The first time I actually really experienced the pervasive multi-threading, as they called it, in BOS, and saw like where I had like 20 large OpenGL videos playing all at once, and the UI was still completely responsive in a way that I just never seen from like a GUI system at that point. That one made me go, wow. There are very few times that I've ever actually gone, wow, but that made me go, wow. Like it was completely outside of my realm of what I thought was possible on commodity hardware at that point in time.
For me, it's definitely the first time I saw and used a keyboard and a monitor. And I could not believe that this was possible, or that just the total transformation between a number 2 pencil and a stack of punch cards. Honestly, everything else that has happened just seems minor and incremental in comparison.
Wow. Well, with that, Sylvan, Sean, thank you both so much for your time. I'm going to give both of you the final word if there's anything you want to say. And again, encourage folks to check out Pony or even contribute to the language if this is something you're interested to. So Sean, Sylvan, any final word is yours.
Thank you for this. This was great. Thank you for that video of yours. That was incredible to watch you with those first impressions. That is like watching people like with that is just great. Yours was just particularly great. That was awesome. I kind of like to come back and do this again sometime, but I would like it to be sort of more like, I'd really like to hear about some of the graphics in the D stuff that you're doing, because I feel like I could learn a thing and we could have some interesting conversation around like that, where it's like, yeah, I don't know, words. What even are they?
Thanks for having us on. I think what you're doing with the series you're doing is really neat. When Sean first sent me that video, partway through, I'm texting Sean going, I really hope this guy is a professor and teaching somewhere because people deserve to be learning from this guy. So I'm pleased to hear that you are and that they do. I think that's really good.
Wow. Well, thank you both so much. And we will do this again. I'd love to do it. And well, for folks watching, thanks for watching, and we'll see you again soon, hopefully.